Okay, friends, so in this video we're going to talk about using Taylor series to evaluate indeterminate forms. So we'll jump into the examples. So I'm going to use a series to evaluate these two limits. Okay, so I do want to just point out here that these are both indeterminate forms. The first one, this is going to give me 0 over 0. And then the second one, this is going to give me like a funkier indeterminate form. So as x goes to infinity, this is infinity. And then this will be sine of 0, which is just 0. So infinity times 0 is its own like indeterminate form, right? And so back in the day, when you didn't know series, you had to do all kinds of like math magic to figure out how to turn this into something that you could use L'Hopital's rule on. And now for both of these, rather than using L'Hopital's rule, we're going to use a series and see if it makes it like easier, I guess. Okay, so let's start with the first one. So the key to this is knowing your basic series. And I've said this over and over in like several videos. So I know that different math teachers can have different requirements, but I think that these are the three like most basic series that you need to know. So we've got this form or we've got the series form, whatever you want to do. So for this example, what I'm going to do is I'm going to write out really like two series, e to the x and e to the negative x. And so when I get to e to the negative x, so I replace all these x's with a negative x. That's basically it. So let's take a look at what that's going to look like. So I am not going to worry about the limit for a second. I just want to try to sort out the algebra here. So let's write this out. So this is 1 plus x squared over 2 factorial plus x cubed over 3 factorial, so on and so forth, minus, okay, so now we've got to do the e to the negative x. So this is 1 plus negative x squared over 2 factorial plus x cubed over 3 factorial, so on and so forth. Oh, negative x cubed, sorry. Negative x cubed. I have been making videos for hours today, so I think my brain is just like hitting the limit of what I am capable of. Okay, so I've got all of this over x. So, if I look through this, I notice that the 1's drop out, right? And then it looks like the x's can be combined. So this becomes 2x. Then I've got x squared over 2. This becomes positive x squared over 2. So then I'm subtracting this off. So these x squareds will cancel out. And then let's see. I've got x cubed over 3 minus, and then this will be negative x cubed over 3. So this becomes plus x cubed over 3. So I think we're seeing a pattern here now. So 2x cubed over 3 factorial. So the pattern here then is it looks like it's just going to double all of these odd factorials. So we'll just continue out that pattern. So I still have to divide all of this by x. So let's go ahead and do that. So I'll make some space. Okay, so now dividing everything by x, I've got 2 plus 2x squared over 3 factorial plus 2x to the 4th over 5 factorial, so on and so forth. Okay, cool. So now I can go ahead and take the limit. So let me clear some space. Okay, so now I can go ahead and take the limit of what's left over. And what's cool about this now is since this is x going to 0, all this other stuff drops out and I'm just left with 2. So this whole thing equals 2. Now, the other thing that I want to mention with this is that you can very easily check that you got the right answer, because this is like your classic L'Hopital's rule. So I just mentioned this because I feel like sometimes, you know, we get so obsessed with using the series, we forget about like the kind of the base knowledge or the basic knowledge that we know. And honestly, I think you should be very proud of yourself if you're at a point in your life where L'Hopital's rule is considered something basic to you. That's pretty cool that you are like at that level. Okay, so what I want to do is, since this is 0 over 0, I'm just going to go ahead and bust out L'Hopital's rule here for a moment, and let's just see if this actually works. So this becomes e to the x plus e to the negative x, right? Because I have to use the chain rule, so this negative will become a positive because of the chain rule, and then all of this over 1. So then if I redo this limit, this is 1 plus 1, so yeah, that equals 2. So that totally checks out. So I just want to bring that up. It's not always possible to like easily bust out L'Hopital's rule. Maybe sometimes it makes you kind of nervous, but this was an easy enough check, so you can always check if you have that time. Okay, so for our next limit, so I've got x plus 1 times sine of 1 over x plus 1. Like I said, this will be infinity times 0, so that is technically an indeterminate form. I'm just going to sort out the algebra first. So I'm going to use my Taylor series of sine of x. And so now where I see an x, I'm going to replace it with what I see here, which is a 1 over x plus 1. So all of these x's will become 1 over x plus 1. Okay, so I've got this x plus 1, and then 1 over x plus 1, and then this will be, we'll write this as 1 over 3 factorial x plus 1 cubed, and then 1 over 5, oops, and I am messing up the, okay, minus, and then plus, okay, sorry, my bad, and then this will be x plus 1 to the 5th, so on and so forth. Okay, so now if I distribute this x plus 1 in, so you can see why this is going to work out nicely. So I'm left with 1 minus 1 over 3 factorial times x plus 1 squared plus 1 over 5 factorial x plus 1 to the 4th, so on and so forth. Okay, so then I can go ahead and take the limit as x goes to infinity, and this makes the limit easy peasy, right? So now, let's see. So now all of these other fractions are going to 0, so I'm just left with 1. So this whole thing, let's see, I'll just write it, I'll write it under here, equals 1. So I didn't have to do any of that other trickery or magic, you know, with algebraically manipulating this. If I wanted to do that, then what I would probably have to do is I would probably rewrite this as sine of 1 over x plus 1 over 1 over x plus 1. This old trick, and then I could use L'Hopital's rule here. So I'll leave that to you if you want to do the check, but you know, it's a little bit debatable whether or not this is an easier way to go. I guess it just kind of depends on how you see things and how comfortable you are with Taylor series, but it's kind of a cool application. Okay, so that brings us to the end of that video. Thanks for watching, guys. I will catch you later. Ta-ta!